All right, so objective 11-4, inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. An intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points with a circle between them. We have a theorem 11.4.1 that tells us that the measure of an inscribed angle is half the measure of its intercepted arc. So here is our inscribed angle. And when we want to know the size of that angle, it would be half of this arc. So what I want you to remember is angle equals half of the arc when it's touching the circle. Here's 3 different examples or 3 different cases of how you might see these inscribed angles and their associated arc. And again, regardless of which one of these scenarios that you have, the angle is half of the arc. Now before, when we worked with these, the angle was right here in the center, and then it was the same. Now the angle is not in the center, it's on the other side of the circle. When that happens, it's half of the arc. Let's work a couple of examples. These are pretty straightforward examples. I have the angle PRU that I want to find the measure of. So here's PRU. So I want to find that angle. So the angle is half of the arc. Since I don't know what the angle is, that's where I put my X. And I say X equals half of the arc. The arc is 118. I want to go to Desmos and I want to type this in. Okay, Desmos. So X equals half of my arc. So X would be 59 degrees. All right. The next problem says, what is the measurement of SP? So I'm looking for arc SP. I'm still going to use my formula. I'm going to say the angle equals half of the arc. And this problem, I know what the angle is, so I would write in 27 degrees equals half of the arc. The arc is what I don't know. That would be my X in this problem. So when I go to Desmos, the X would become 27, and I would put an X where the arc goes. So there's my answer. I got to zoom out to find it, but my answer is 54. So that arc measure would be 54 degrees. Now, this is a common sense kind of a thing. I've got this scenario of these 3 arcs. These 3 angles. I've got one at C, one at D, and one at E. If you notice, all 3 of those angles are at this arc. So if all 3 of those angles share that arc, then that means that all 3 of those angles would be congruent. All right? So what does that mean? Well, it means if they're congruent, I can set them equal to each other. So in my example 5, I've got these 2 angles right here, 5B minus 7 and 3B. Notice that they both of these angles are right here at LM. That means they both have endpoints at LM, so they're both the same measure. Now, this time I'm not going to use the formula because they're equal to each other. I'm going to set them equal to each other. So 5B, let me make that an X because y'all always tell me that my B's and my 7s, boogers, You guys always tell me that my B's and my 6's look alike and you're not real sure what they are, so I'm going to use X. So 5X minus 7 equals 3X, and that's exactly what I need to type into Desmos. So 5X minus 7 equals 3X. X is 3.5. All right. Now, it actually wanted me to find LJM. LJM. So, the problem wants me to find the measure of that angle. So, the measure of angle LJM equals 5X minus 7. So now I have to substitute, or I have to input my X value in. Pull the calculator back out because I'm not going to try to do that decimal in my head. I'm going to let Desi help me because she's my best friend in the whole world. And I get that angle, that arc measure. What am I talking about? I'm talking about an angle. So that angle, and that's the difference. It's got an angle symbol instead of an arc symbol. So that angle is 10.5 degrees. All right, that's pretty basic problems. It's pretty much the kind of problems you're going to have on IXL. I got another theorem that says if a triangle is inscribed in a circle and it's a right triangle, so I have to know that this is a right triangle, then the hypotenuse is the diameter. So the hypotenuse is here. So the measure of AC, so I'm going here, the measure of arc AC would be 180 degrees. Oh, that's a good question. You're wanting to know why it's not half. Well, I'm at the center. So since I'm at the center, it's going to be the same. And that's a straight angle. How are we going to use that? Well, when we look at these triangles and we see that there's a triangle inside of a circle, if I see that this one of these legs of the triangle is the diameter, then I can automatically say that this angle across from it would be a right angle. And what does that let me do? Well, that lets me solve for a variable. So, in this problem, 5x plus 20 equals 90. X is going to equal 14. Now, obviously, of course, it was an A, but we know we have to type in an X. Same thing here. This is a diameter. Since that's a diameter, I know that 8z minus 6 is going to equal 90. So same thing. I'm just going to retype this and say 8x minus 6 equals 90. Z is going to be 12. All right, so. All right, new concept. Another theorem. If we have a quadrilateral inscribed in a circle, then its opposite angles are supplementary. So, E and G. All right, E and G. We're talking about these red angles right here. When you add those together, they're going to be 180. D and F, the blue ones. When you add those together, they're going to equal 180. Now before, when they were side by side, they equaled 180. Well, now we're changing it up a little bit. When they're across from each other, they equal 180. How does that work? Well, pretty basic. If I wanted to find y, let me change it to red here, I would say y plus 120 equals 180. Y is going to equal 60. All right, that's just some simple algebra solving. Z plus, well, that's a funny looking plus. Z plus 45 equals 180. All right, do you want to see this written out or typed out? You would say X plus 45 equals 180. Z equals 135. All right, the other way you could do this is for G and 75 equals 180. So I could just say 180 subtract 75, and that's going to be 105. And then for H, 180 subtract 100, that leaves me with 80. And all of these would be a little degree symbol. Now, that's a lot, and you need some practice with it.